In this video, we're going to have a look at how we can solve trigonometric equations that involve a negative value on the right-hand side of the equal sign or right-hand side of the equation, and that have a domain that's less than 0. So considering this or these questions here, so Cambridge Chapter 12H, question 5, you've got for A, you've got this negative here. For and for C, you've got the negative here. So we'll do an example of how we deal with these sorts of problems. So consider if we've got sine of x equals, and we'll say negative a half, and we'll do it over a domain of negative pi and pi to match it with the question. So what we're going to do is we're going to solve this equation on the left here. So sine x equals negative half over a domain of negative pi and pi. Alright, so what you might first be inclined to do is simply to go x equals the inverse sine of negative a half, and then it will spit out negative pi on 6. So that might be your first intention, but it's probably not the most conducive method to take at this point in time, because you don't really want to be dealing with negative numbers straight off the bat like that. But rather, a better way to look at it is to simply draw a unit circle like so. Nice unit circle. And then recall that usually when you're dealing with these problems, you ask yourself, or when you're dealing with a problem involving sine x, you ask yourself, well, where is sine positive? And you'd say it's here and it's here. But notice we're not dealing with where sine is positive, but rather because the equation here, we're dealing with a negative value on the right-hand side of the equation. We're looking for when the output of this sine x is equal to negative. So what we're going to do is pick the third quadrant and the fourth quadrant, because sine is negative in these two quadrants. And then I'm going to write out the equivalent equations for finding the angle in these quadrants. So let's say that in quadrant 3 we know that the interior angle of the triangle formed is going to be theta minus pi. And then for quadrant 4, it's going to be 2 pi minus theta. And the question at hand is, well, what's the theta? And the theta in this case is, the way I like to do it is, rather than having this negative here, what I'll do is I'll go theta equals the inverse sine. And rather than having a negative value in here, I'll completely ignore the negative and simply put it in as the positive, and then I'll get the subsequent output of pi over 6. And I'll use this value here as like a synthesis for finding the solutions for later down the track. Alright, now, before we go any further, what we'll do is we'll have a look at a quick sketch of what we're doing. So what we've got is our Cartesian plane here, and recall that we're looking for sine of x equals negative a half. So if we graph just the basic sine of x, from 0 to pi or 2 pi, we're going to go up, then down, then up, and we'd say that that's 2 pi radians there. But notice that we're not working to 0 to 2 pi, we're working to negative pi to pi. So rather we're working from, it's a bit messy, we're working from pi radians, just there, and we're working backwards, like so. And this would be negative pi radians here. Negative pi radians. And then we're asking ourselves, well, when is the output of this sine function going to equal -1/2? So I'll draw my line through here, and we'll say that that's going to be y equals -1/2. And the point, or the question at hand is, well, when does it cut? It's going to cut here, 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 and here, and here. All right. Now, this is really important to keep in mind when we start getting our solutions. So firstly, we can already see that we're just expecting 2 solutions over this period. Now, going back to our unit circle, we're expecting our solutions to be in quadrants 3 and quadrants 4, and the equivalent triangle that we formulated in quadrant 1, we're going to use that angle, pi/6, to get the values for what we'd expect in quadrants 3 and 4. So what I'm going to say is for quadrant 3, we're going to go pi/6 equals x minus pi. So I turn this theta back into an x because we're working in terms of x here. Now solving for x, it's going to be x equals pi/6 plus pi, and that will come out to 7pi/6. So x equals 7pi/6. Now going back up to our diagram, we ask ourselves, does this solution of 7pi/6 fit within where we're expecting? And the answer is sort of yes and no, in that, well, it's outside of our domain because it's above pi, so it is here. So this would be 7pi/6, and it equals a value of -1. So it's sort of on track to getting to the solution, but it's not our first solution. Rather, our first solution is here, which we'll deal with in a second. Now, to get to the subsequent possible solution, we have to go for the 4th quadrant here, and we'll go pi/6 equals 2pi minus x. Then solving for x, we get x equals 2pi minus pi on 6. And this is going to give us a value of 11pi/6. So notice once again we're outside of our domain because we're well and truly above pi radians. So what we find is that this solution here, 11pi/6, is well in fact 11pi/6 and -1/2. So these two guys that we've just found, they're on the downward swing after pi radians here. What we need to find is these two solutions here. So how do we do it? Well, what we're going to say is, we're going to say x equals pi on, whoops, not pi, but 7pi/6 plus 2k pi, and then we're going to say 11pi/6 plus 2k pi. And then recall, whereabouts are we expecting these solutions to land? And we're expecting them to land sort of on just to the left of the y-axis here. So what we're going to say is, we can say where k is an integer of -1. So putting that all together, x equals 7pi/6 minus, so k is going to turn into -1, so it will be minus 2 pi. And then the next one will be 11pi/6 minus 2 pi. Moving downwards, we're going to have 7pi/6 minus 12pi/6, 11pi/6 minus 12pi/6, and then 7 take 12 is going to be -5pi/6, and then we're going to get -pi/6 over 6. So therefore, our two solutions for this particular equation that lie within the domain of negative pi and pi are going to be negative 5 pi on 6. Oops. So negative 5 pi on 6, as you can see here, and negative pi on 6, as you can see here, which would be, if you would graph this on your calculator, you'd find that the solutions would be here and they'd be here. So this is an example of how we'd find, or how we'd solve how we'd solve equations that involve trigonometric functions that equal negative values.